What is explicit instruction? Explicit instruction is instruction that is systematic, direct, engaging, and success-oriented. It refers to an instructional practice that carefully constructs interactions between students and their teacher, and means that the actions of the teacher are clear, unambiguous, direct, and visible. There are 6 vital features that encompass explicit teacher-directed instruction. The teacher will start with a daily review of previous lessons and revisit pre-skills for the upcoming lesson. The teacher will then present the new content by modeling, demonstrating, and asking frequent questions, as well as encouraging students to actively participate in their learning. Once new information is acquired by students, the teacher will provide several opportunities for guided practice. During guided practice, students will receive explicit feedback and corrective instruction for any mistakes. There will be reteaching to struggling students, independent practice opportunities to build proficiency and fluency, and systematic practice providing weekly and monthly reviews to maintain mathematical concepts and skills. There are different explicit teaching principles embedded within each tier of RTI math instruction. Tier 1 of RTI is also known as response to instruction. Ricamini and Witzel state that differentiation in Tier 1 is about what students need in order to succeed. They further discuss that the purpose of Tier 1 is to help students achieve in mathematics. Tier 1 should include general education curriculum that is supported by research, as well as researched instruction. Tier 1 delivers curriculum in a manner that meets the needs of the students in the classroom. The strategies found in Tier 1 include, but are not limited to, differentiation by class configurations, providing extra assistance, and peer groupings. Tier 2 is considered the first line of intervention for students not meeting benchmark standards. Key components of Tier 2 interventions, as defined by Pierangelo and Guilani, include the size of instructional group, mastery requirement of content, frequency of progress monitoring, duration and frequency of the intervention, and instructor considerations. Reducing the group size in Tier 2 allows the teacher to create more flexible groupings, which can lead to increased engagement and motivation as well as more individualized mathematics support. Small group work further allows for more student response and teacher feedback, and lets the teacher implement more intensive interventions. It is also important that an intervention leads students to success in areas where they were previously weak. The effectiveness of assessment should be monitored closely. Duration of the intervention is dependent on student outcomes. Once the effectiveness of an intervention is determined, a decision can be made as to the next steps for a student. Hudson and Miller emphasize that the person who implements the intervention strategy must be qualified to provide the intervention and must understand assessment and child development such that he or she can make appropriate adjustments to the instruction necessary to deliver that particular curriculum that the student is learning. Tier 2 should be taught in a separate setting for most of the week in a time period that lets the intervention be delivered, and it includes teacher-led explicit instruction. Students who receive Tier 3 intervention or alternative instructions are students who are performing below standards and have not adequately responded to Tier 1 instruction or Tier 2 instruction. Tier 3 students have deficits that appear across the content areas rather than just 1 or 2 subskills. Tier 3 is a more intense in student participation and interaction and more personalized to the specific needs of the students. Because of the individuality of Tier 3 curriculum, the curriculum might not necessarily be based on state standards, but rather on the transition needs of the student. There are 4 main instructional domains in mathematics instruction: conceptual understanding, procedural knowledge, declarative knowledge, and problem solving. One of the primary goals of mathematics instruction is to promote conceptual understanding of mathematics so that the students will be able to understand and generalize their learning to real-world activities and settings. There are many strategies that can be utilized in the instruction of conceptual understanding. 2 such strategies are providing non-examples of the concept and using manipulatives. Providing non-examples of a concept helps the student understand what the concept is not. It is important that more examples than non-examples are used when teaching the concepts. Hudson and Miller also suggest that for every non-example, at least 3 examples should be provided. Using manipulatives within different parts of the lesson can be extremely beneficial for all levels of learners. Hudson and Miller point out that it may be helpful to use different manipulatives during each lesson to promote generalization of the concept being taught. Unifix cubes, plastic links, base 10 blocks, fraction pies, money, and a clock are all examples of beneficial manipulatives. Procedural knowledge is essential for many tasks that teachers ask students to perform in mathematics. Instruction in procedural knowledge requires the teacher to develop, demonstrate, provide guided practice in a procedural strategy for solving the specific type of mathematics problem. A procedural strategy is a set of sequential steps that lead to the solution of a problem. One strategy that can be implemented is the use of mnemonics, such as SAW and DRAW. SAW stands for set up the problem to solve, attack the problem, and wrap it up. DRAW, developed by Mercer and Miller, stands for discover the sign, read the problem, answer or draw and check, and write the answer. Students may also greatly benefit from verbal rehearsal of the procedural strategies. Rehearsal can be practiced in group, peer-assisted, individual, and rapid-fire form. Group rehearsal is used after teaching the procedural strategy to the students. Peer-assisted and individual rehearsal can be used when students are comfortable with the group verbal rehearsal process. And rapid-fire rehearsal is used after the students have sufficient practice to memorize the strategy steps. Declarative knowledge refers to information that students retrieve from memory without hesitation. Declarative knowledge helps students succeed as they move through mathematics curriculum. Hudson and Miller point out that the ability to memorize and quickly retrieve memorized information is particularly important due to the hierarchical nature of mathematics. One strategy that can be used when teaching declarative knowledge is constant time delay. When using the constant time delay strategy, the teacher presents the problem to the student. The student then reads the problem out loud and is given a short, specific amount of time to say the answer if she knows it. The student is told to wait for the teacher prompt if the answer is not known. If the student does not say the answer within the designated amount of time, the teacher will provide a controlling prompt where she reads the problem and states the correct answer. The student will then reread the problem and say the correct answer. Another strategy that can be used when teaching declarative knowledge is 1-minute timings. In this strategy, students are given 1 minute to correctly answer as many math problems as possible. According to Hudson and Miller, the time aspect of this procedure, coupled with counting and recording the number of correct answers after the timing is complete, both serve as motivators to most students. The final instructional domain is problem solving. Problem solving requires a thorough understanding of mathematical operations and their meaning, as well as the ability to transfer this knowledge to real contexts. Though there are many strategies that can be used in the instruction of problem solving, 2 will be discussed. Schema-based instruction is one beneficial strategy. Schema-based instruction involves the use of schema diagrams to represent various types of word problems. There are 2 primary components of schema-based instruction: identifying the problem schema, and writing the critical information on the diagrams, and selecting and executing the correct arithmetic operation to solve the problem. To use this strategy successfully, students must be able to identify the total or larger quantity in the problem. A second strategy that can be implemented in the classroom when teaching problem solving is the number family approach. When using the number family approach, students are taught that 3 numbers can be used to create 4 mathematical statements. Hudson and Miller identify that the critical element in using this approach for solving addition and subtraction word problems is teaching students to recognize whether the total number is provided in the word problem. The effectiveness of explicit instruction has been validated time and time again with both general and special education students. Archer and Hughes pinpoint the importance of explicit teaching instruction. They say that while explicit instruction has proven to be very helpful for normally progressing students, it is essential for students with learning challenges. There are countless strategies to utilize and implement within explicit teaching to best meet the individual needs of each student. Sometimes, educators need to be willing to exhaust every option until one that benefits a struggling student is found and implemented effectively and successfully.